In this video, I'll be reviewing some theorems on perpendicular lines. So our first three theorems are labeled as just 1, 2, and 3 for us today, so we can easily reference them later on in some examples. But our first one is telling us that if two lines intersect to form a linear pair of congruent angles, then we can say the lines are perpendicular. So looking at this picture, if we are given the fact that these are a linear pair, we know that they are because they are both sitting on line A, and we're told that they're congruent. You can see that they're both marked there as the right angle. For both of those reasons, we're able to say that line A would be perpendicular to line B. And we can say that using this notation. Just like when we learned about parallel lines, if the lines had been parallel, we put that parallel symbol in between them. Now we have this perpendicular symbol that looks like this. In Theorem 2, it says if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So, for example, because this is line M intersecting with line N, and this was made a 90-degree angle, that means that this would also have to be a 90-degree angle, so angle A plus angle B would equal 90. They would be complementary to each other. And in Theorem 3, it says if two lines are perpendicular, then they intersect to form four right angles. So if we were given that line A and line B are perpendicular, then we would know that all four of these angles are 90 degrees. So the measure of angle 1 would equal 90 degrees, and you could say it for angle 2, angle 3, and angle 4. We have two other theorems having to do with perpendicular lines that we're going to look at today. The first is the perpendicular transversal theorem, and this tells us that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So that means you need to know that the lines are parallel, and you need to see that it's perpendicular to at least one of them. That would mean that we could conclude that line J is also perpendicular to line K. We would have needed to know, though, that these were parallel first and that this made that 90-degree angle, that it was perpendicular to H. Our other theorem says that lines perpendicular to a transversal theorem in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if two lines, so L and M, are perpendicular to line N, then we can conclude that line L will be parallel to line M. But that was because N was shown as being perpendicular to both of them. So we're going to apply all of these on the back here. And in the first section, it's saying, what can you conclude based on the given information? Well, in the first example, they tell us that angle 1 is congruent to angle 2. We can also see in the picture that angle 1 and 2 are a linear pair. That means that angle 1 plus angle 2 would need to equal 180 because they are a linear pair. And if they're congruent, that must mean that they both are 90 degrees here. So if they both need to be 90, then we can say that the lines are perpendicular. So we could say line R is perpendicular to line S. And this was our Theorem 1 from above, if you want to go back and reference that. In our next example, we're given that line N is perpendicular to line M. Remember, that's what this symbol means, that they are perpendicular. So if we're given that two lines that are perpendicular intersect, that tells us that angle 1 will be 90 degrees. Angle 2 will also be 90 degrees. Angle 3 will be 90 degrees. And angle 4 will be 90 degrees. This was from theorem number 3 from above. And in our last one in this box, we have line AB is perpendicular to line BC. That tells us that they are intersecting at a right angle. So what we can conclude with that is that angle 1 plus angle 2 will have to equal 90. These two angles are complementary to each other, and this was from Theorem 2 above. So continuing to apply these theorems in this next set of examples, our first one tells us that we need to find x. So in this diagram, we are going to say that because these two lines are perpendicular, and we're going to say that this is actually going to be part of the given information, and I should have included that, but we're going to say that this is given, that these two lines were intersecting at a 90-degree angle. then we can conclude that these will also be intersecting at a 90-degree angle. So we can add 25 plus the other part of the angle, x plus 25, and they should equal a total of 90. Once we do that, we can just combine like terms and say 50 plus x equals 90. We subtract 50 from both sides, so x will equal 40. That means that this angle measure will be just 40 plus 25, which gets us 65 degrees. In the next picture, we are given a bunch of different lines that are intersecting at various places, and some angles are marked, some aren't. Angle 1 is given to us with the box. This is identifying that it is a 90-degree angle. From there, we're going to use some conclusions from our theorems today to help us figure this out. So it looks like angle 1 will be a linear pair with this angle, and because that was 90, the other one must also be 90. So because we know these two angles will need to add up to 90, and we're already given that one of them is 60, we can get angle 2 by subtracting 60 from 90. That will mean that angle 2's measure is 30 degrees. To get angle 3 now, I'm going to just take a look and see, well, what do I already know? And I can see that angle 3 is actually a vertical angle with this angle that we have been given right from the start. So these two are vertical. So we can conclude that angle 3 would be 60 degrees. Angle 4 can also be found in that way. So if we are looking at angle 4, we can see that that is vertical with angle 2, and we already figured out that angle 2 would have been 30, so that we can say that angle 4 is also 30 degrees. For angle 5, we're going to use some of what we've already discovered. Angle 5 is complementary with angle 3, and we already figured out that angle 3 is 60 degrees. So that means to find angle 5, we're going to take 90 and subtract 60, and that will give us that 30-degree angle that angle 5 is worth. And finally, for angle 6, we can do something similar. We can automatically say that this angle 5 plus 6 will be 90 because it's vertical with this given right angle. And so because those need to add up to 90, if I'm trying to find 6, I can just say 90 minus the 30. Angle 6 would have to be 60 degrees. And then finally, in our last example, it's saying determine whether the following statements can be made. So this is where we're going to use some of our theorems. And the first statement that's trying to be made is that R will be parallel to S. Well, if we focus on line R and line S, we don't know if they're parallel. For these two lines to be parallel, we have to say that the transversal that cuts through them, we would need to be given the information that this transversal is perpendicular to line R, or transversal N would have to be perpendicular to line R. But because that information was not given to us, we are not able to conclude that line R is parallel to line S. So there's actually not enough information here to conclude this. For line M and line N being parallel, we're checking all the transversals. Transversal T doesn't give us enough information. We know it's perpendicular to line N, but we don't know if it's perpendicular to line M, so we can't decide that. We can see that for the transversal S, it is perpendicular to N and it's perpendicular to M. So yes, because of transversal S. You can see those both cutting through. Those will tell us that because it's perpendicular to each of those lines, then that means that line M must be parallel to line N. And then finally, in our last claim, it's saying that line S should be parallel to line T. So when I look at the transversal M, I can see that that's perpendicular to S, but I don't know that it's perpendicular to T, so we can't make that claim. But then when I look at transversal N, I can see that that's perpendicular to line T and line S, which means that because it's perpendicular to both of them, we can claim that those two are both parallel.